Good morning. Today we move on to circular motion, and in particular today is going to be about centripetal acceleration. Some of you might have heard the people at the carnivals talk about centrifugal acceleration, but that's not a word we use in physics. We use centripetal acceleration, and that is linked to the fact that velocity is changing. So this here is my path that my object's taking. It's going around and around here. That's the central axis. And we're going to start looking at this first spot over here. So we'll call that velocity initial. So I'm going to draw a vector on that shows that initial velocity. And we'll make it come all the way up to here. That there is VI. Because this object is moving at a constant speed, the length of that vector stays the same. So I'll measure it up, and it is 50 millimeters. Once it's had a little bit of time, the object has moved from there around to, we'll say, this point. Remember, it's moving the whole way around, but we're going to analyze it again at this point. So I'm going to draw my vector, which will be exactly the same length, but now the direction has changed. It's now going down here. Still 50, which represents that it's doing 50 meters per second there. Still doing 50 meters per second there, but you can see the direction has changed. The direction is always tangent, and that will be assessed in your exam. Tangent means that it's at 90 degrees to a line that's going from the center out to the edge. So that line there, we've got 90 degrees there. If we come and check with this one, you can see again we've got 90. This vector here is going to be called VF. Our job now is to do vector subtraction, just as we did in the last topic, and our formula can still be exactly the same. So change in velocity is equal to VF minus VI. However, can't do minuses when we're dealing with vectors, so we do that little switch just like we did in the last topic. VF is plus negative VI. Mathematically, it's equivalent, and that allows us to do it with vector arrows. So now we're going to take our VF, which is pointing straight down. We're going to get the direction the same and the length, and we're going to draw our vector triangle down here. That one there is VF. Now we're going to take VI, and we're going to add to it. So it's 50 long. VI goes this way. We're interested in negative VI, so that goes the opposite direction. So I'm going to keep that the same. We've got to add it on, so it goes down this end here. And that there is negative VI, pointing in exactly the opposite direction to VI. To find out the change in velocity, we just go from the start of our vectors to the end. That one there is called change in velocity. And that there covers the work on page 164.